So we're supposed to rank the following molecules in order of highest to lowest boiling point. So using the attractive forces. So here we deal with the intermolecular forces. That's the very first step we deal with. So so for this first molecule, then we see that we have this part right here is nonpolar because it's just a carbon-hydrogen part of it. But this part right here, so the difference in electronegativity between the nitrogen and the carbon right here is, so this is, so it's greater than 0.4. And so it's a polar bond. So this is partially negative, this is partially positive. And we can separate those two with a straight line. And that kind of helps us to know that it's polar. But since it's polar, it's either dipole-dipole or hydrogen bonding. And since hydrogen is bonded directly to nitrogen in this case, we know it's a hydrogen bonding. So remember, hydrogen bonding is when nitrogen's bonded to hydrogen, or oxygen's bonded to hydrogen, or fluorine's bonded to hydrogen. But if it's not directly bonded, then it's not, okay? So all of these are hydrogen bonding for the same reason. Okay. And then this bromine, so if we look at the electronegativity value for bromine, let me just look it up here. So for bromine is 2.8, and for carbon it's 2.5. So the difference is only 0.3, so that's considered, I mean it's polar, but it's not polar enough to worry about, so we can neglect that. So therefore this is nonpolar, that means it's London dispersion. And this last molecule, because of this, we don't have to worry about anything else. Because there's a metal in it, so I don't know why it was drawn this way, but these are kind of connected here and here maybe. So if you look at magnesium, it has 2 valence electrons. So one of those valence electrons is to here, one of them is to here. And anyway, so this is an ionic compound, therefore it's an ion-ion intermolecular force. All right, so the strongest intermolecular force here is ion-ion, and so the order, if you remember, ion-ion is the strongest, then hydrogen bonding, then dipole-dipole, and then London dispersion is the weakest. So if it has the strongest intermolecular force, it's going to have the highest melting point or boiling point in this case. So we're going to label, let's see, since the ion-ion, so it says from highest to lowest. So this is number 1 because it's the highest because it has hydrogen bonding. And then all of these guys, sorry, not hydrogen bonding, ion-ion. And these 3 are hydrogen bonding, so they're the next highest. But since they all have hydrogen bonding, which one is the highest? And it's all about the bigger one. So they all have the same elements in it. This one has more of them, so this one's the largest out of the 3, so that one's going to be number 2. And then out of these 2, this one has the lowest surface area. So in other words, the smallest out of these 2, even though they're the same number of carbons. I have 1, 2, 3 carbons here, 1, 2, 3 carbons here. But this one is larger in size, so that's number 3, and this one would be number 4. And then this one is number 5 because it's London dispersion way down here. I hope that helps. If it doesn't, please let me know.